Okay. Now, we have seen that if the acceleration is uniform, v of t is a linear function of t, and it should come as no surprise that if v sub 0 stands for v of 0, that the constant that we get on our v function, the v-intercept, is going to be whatever v0 is. So this is where v0 equals v of 0. And also, we wrote that down here too, also x of 0 is x0, and if so, the x of t function comes out like this. Okay? This part follows just from the way the x of t function follows from the v of t function. Most people are calculus literate, so this is just a general antiderivative of this, but with the condition that x of 0 equals x sub 0. So we have these two functions. We have our velocity function and our position function. Okay, and this is important. This is kind of a summary. This is getting closer to the notation of your textbook. And I didn't want to just start you with the equation, with the notation in your textbook, because you would have memorized these things as formulas rather than understanding where they came from. You know, if you still don't understand where they came from, they're going to work for uniformly accelerated motion. They only apply when the motion is uniformly accelerated, because this implies that you have a constant slope in your velocity versus time graph, this being a linear function. And the quadratic x function follows from the fact that an antiderivative of a linear function is a quadratic function. Now there's another way to understand what happens during any time interval, and it's by the v versus t trapezoid. We have vi for the initial, vf for the final velocity on an interval of length delta t. Now we don't put any y-axis on here. We don't know where this is in the y-axis. Clock might have started at the end of the last ice age, whatever instant that occurred. So we don't know how the clock is running. We don't even know when the clock started, but we measure a time interval between here and here somehow on a clock that's been running for 10,000 years. So when we have this trapezoid, we have to be able to find the slope in the area, and our result should be consistent with this. So that's something we're going to be looking at. But you should write out what's the slope and what's the area of that trapezoid. Now there's much more that we'll do with these, and we'll do that in the next class. But for now, make sure we understand where this came from, and we understand that this is a model of motion, of velocity versus time for motion on a single interval.